Okay, we are going to do arithmetic means. Arithmetic means are two non-consecutive, that means not right next to, terms in an arithmetic sequence. There are two ways to do these. One way is very algebraic. Um, well, I guess kind of just figuring it out. So we would go plus D, plus D, plus D, plus D. So it's 21 plus 4 common differences ends up at 45. So this is more of a, hey, let's just figure it out type of thing. And I get 24, and I get D is 6. So then you go up here, you're actually looking for the numbers that would be equally spaced in between. So it's kind of like looking for the ones that average out. That's where the mean comes from. So I get 27, 33, 39. Make sure it fits. The other way you can do this is you can call this A1 and this A5. And so you can go, the value of the fifth term is equal to the first term plus 5 minus 1 times the common difference. So now we're using the formula an equals a1 plus n minus 1 times d. Okay, look at, it's the same problem that we did over here. It's just that sometimes you don't have that visual. So you know that they gave you 3 arithmetic means is what they wanted in between. That makes the first term, that makes the last term. That's where your 5 term comes from. And we would solve that and get the same thing. So the same thing here, 3 arithmetic. We're not always looking for 3. It just happens that these are the same. So again, you can do 1, 2, 3, 4. 13 plus 4d equals 25. 4d equals 12. D is 3. 16, 19, and 22. And make sure it works on the last one. That's how you make sure you didn't make a mistake. Geometric, going to be a little different. 3.12. 1, again, we're doing 3. I'm not sure why all these examples are 3, but it doesn't have to be 3. Okay, so now we're doing R. Again, 2 ways to do it. Times R, times R, times R, times R. 3.12 times R to the 4th equals 49.92. Divide by 3.12, divide by 3.12. Take your calculator. 49.92 divided by 3.12. And I got, whoa. I got the wrong answer. I got 16. And now we might remember back that 2 to the 4th is 16. Maybe we don't remember that, though. So how do you undo a fourth root, or to the power of 1/4 is the fastest? R is 2. Again, you could go nth term, fifth term is equal to the first term times the common ratio raised to the 5 minus 1. It's the same thing. It's 3.12 times r to the 4th. You can use the formula as well. Again, we do 3. I'm not sure why we do 3 every time, but we're hot. So the last term is equal to the first term times common ratio 1, 2, 3, 4, 5 terms. So I'm going to divide by 12. And I'm going to do r to the 4th equals, ooh, that's going to be a little number. And that's okay, because we're getting smaller each time, right? And I get 0.0625. 0.0625. And I raise that number to the 1/4. And I get 1/4. 1/4. And I get 1/2. Again, 12 times a half is 6 times a half is 3 times a half is 1.5. Did I finish this one? 3.12 times 2 is 6.24 times 2 is 12.48 times 2 is 24.96 times 2 is the right answer. These are the means, right? You find the common ratio to find the means. Okay, we are not doing sigma notation today. We are skipping over to here. A converging series occurs when the R is a fraction. that means you're getting smaller and smaller and smaller. Okay? So it can be positive or negative, and that's why it says absolute value. So here, I have a first term of 5 and a common ratio of 1/2. That means it converges. That means we're going to head towards a value, okay? And that means in this one, we can almost see it's heading towards 10. There's going to be an asymptote because you're multiplying by a smaller and smaller and smaller number to the point that that number approaches 0. And if you're adding on 0, then you are where you are, right? That's different than when our absolute value of r is greater than 1. So here, our r is 2, so that does not converge, it diverges. The sum will head towards positive infinity or negative infinity. So you're really focused on the value of r. Is it converging? Remember, r is the second divided by the first. In this case, it's 0.3 repeating, or 1/3. So that means it converges. It's convergent, okay? Because the absolute value of r is less than 1. That means we're going to get smaller and smaller and smaller. If I continued on, I would go, what, times a third, 81. What is 81 divided by 3? 27, and then plus 9, and then plus 3, and then plus 1, and then plus a third, and then plus a ninth, and then plus a 27th, and then plus an 81st. So I'm getting so small that my number is just going to head towards a value because I will no longer be adding on anything of significance. Second term divided by the first term is 2.5. That means it's divergent. Okay, the absolute value of r is greater than or equal to 1. That means it's getting bigger, so it does not converge. It goes to it's an infinity. The great thing about when they converge, so the sum of an infinite, so we can find the sum of an infinite number of terms. And the reason is we go s to the n equals a1 times 1 minus r to the nth over 1 minus r. And what happens here is the reason this disappeared. I'm going to do 1 minus a fraction, call it a fraction, call it 1/2, sure, raised to an infinite number, okay? If you're going to take a fraction and raise it to infinity, you're going to get 0. Think about multiplying a half times a half times a half times a half times a half. If we just did the number 1 times all of those things, we would get 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, 1 over 120. And I'm just going, that's like the 5th term, and I'm already at 0.00 something. So this turns into the number 0, and 1 minus 0 is 1. So if we know that r is less than 1, we can get rid of that. And look how fast. It's the first term divided by 1 minus r. And that's only when r is less than 1. If r is greater than or equal to 1, the absolute value, it doesn't have an infinite sum. So these are specific. So if I'm going to take this guy here, if I find the r, 4 divided by negative 4 over 3, that gives me negative 3. And the absolute value of that is greater than or equal to 1. So this is no sum. Okay, so you're focusing on this number. So we look at this one. Negative 3 over 2 divided by 3 is going to be negative 1/2. This is good. This is good. It exists. The infinite sum is equal to the first term divided by 1 minus the r. Okay, that's going to be 3 over 1.5. What is 3 over 3 over 2? It's going to converge to 2. The sum will be 2. Think about this. 3 minus 1.5. 3 minus 1.5 is 1.5 plus 0.75. Now we're at, after 3 of them, we're at 2.25. Now I'm going to minus off 3/8. So now I'm minusing off 0.125, and so on and so forth. So we're going to keep going down and up and down and up and down and up and down and up, and then we'll settle in at 2. So it's just the first term divided by 1 minus r. Real easy formula. Determine if the geometric sum exists. R is equal to the second term divided by the first term is 2, no sum. And, well, actually, this one is, the first term is 5, and the common ratio is a half. Let's find it. This is actually the first one that we had. So the infinite sum is equal to the first term divided by 1 minus 1/2, which is 5 over a half. 5 divided by half, flip the second guy and multiply, it's 10. And if you go all the way back to right here, this is, whoa, 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 this is 10. We converged to 10, and you can see it. And I'm already at 7.5, 8.75, and so on and so forth. All right, that's it.